Hello and welcome to Stats for the Masses webinar, GIGO No-Nos, Problems and Solutions in Data Preparation. My name is Elaine Eisenbeisz. I'm the owner and principal statistician here at Omega Statistics. We're re-recording this from February. We had a glitch in our audio, and so it did not record, even though people did attend a live event. And then I got a bad cold with bronchitis, and I've been coughing about the last month. So if I'm a little bit quiet on and off today, it's probably because I'm taking a sip of tea, but hopefully we can get through this and get it done. And I thank everybody for their patience in waiting for this. I know you were wanting to see this. Today I'm going to present a rather simple cleaning of a rather small data set for use in multiple regression. It's important to know how to learn to understand your data and how to use your data properly in the analyses to test hypotheses. Today is just an overview, but I hope that the information you receive today will give you some ideas and guidance on using data properly. The reason we call it GIGO No-Nos is because you put garbage in, you will get results, but they probably won't be valid. So a lot of times you'll run an analysis and for a regression, for instance, and you get very nice coefficients and everything, but they're just not valid because your data wasn't input properly and analyzed properly. It's my hope that if nothing else, you'll come away from today's presentation feeling a bit more in control of your capabilities as a researcher. Too often we're afraid of making adjustments to the data because we're under the impression that if we make any changes, we're going to invalidate something. But more often than not, using data as it is without regard to the structure or the type of analysis you're going to be using is far more egregious. So you should feel comfortable with manipulating the data in ways that are valid and appropriate for your analysis. The presentation may run a bit longer than the other ones we've had. However, I'd like to finish in about 45 minutes. Usually we have a Q&A afterwards. However, since I am re-recording, it's just me today. We don't have an audience. My assistant Heather's not here to ask the questions from the audience. So feel free to email me. You can find it on our website, www.omegastatistics.com. My email is elaine@omegastatistics.com. I'm sure it's at the end of the slides here, and I'd be happy to answer any questions you have. Okay, so before we begin, I do want to take a minute or two to tell you about Omega Statistics. We're a private practice statistical consultancy. We're based in Southern California. We do just about everything, medical and clinical research. We do exploratory and predictive modeling, exploratory design where we're trying to find some things, dissertation assistance. Many of our clients are working on their methodology or the results chapters for their dissertation, and we do help with those. We do design surveys and help with that. Projects of any size, individuals, big businesses, government, we help just about everybody. Our motto is Elegant Solutions Effectively Applied. We do have another webinar coming up in May, and I'll tell you a little bit about that at the end. It's going to be working with missing data. But today we're going to learn how to clean it up. So I think that'll be very, very interesting. So let's go ahead and get started. How do I clean my data? Well, the textbook is, I always try to find a textbook one, and I swear I don't try to find the hardest one, but sometimes they do crack me up in you know, what they could say in a sentence they're saying in a paragraph. Data cleansing is the process of altering data in a given storage resource to make sure it's accurate and correct. Storage resource could be a database, it could be your Excel file. You know, I mean, half the time you look up a definition and then you have to look up other words that are in the definition just to try to make sense of it. Our Stats for the Masses way of saying it is data is dirty. Don't take it anywhere until you clean it up. Cleaning data is preparing it so that it can be used properly in analysis for valid results. Okay, it's not playing with the data to give it the results you want, but it's manipulating it and doing what you need to so that you get valid findings. And you'll find most of the time data is dirty, messy in real life. It's not like a textbook where it's nice and pretty and ready to go. So you usually do have to do a lot of cleaning. This one's going to be very simple, though. Nothing like cleaning a huge database. We're going to keep it simple today. So the data collected was from a study. It investigated biofeedback as a stress relief technique. There's the perceived stress scale. It's a 14-item scale. There's also 10-item versions. I think there's a couple other versions of it. But we use this to assess stress scores before and after a biofeedback training intervention. A multiple regression will be performed with the post-training PSS 14 score. So basically what we did is we had 112 people. We split them up into two groups. The experimental group got the biofeedback training, and the control group did not. So everybody, all 112 people, were tested with the PSS, and then the experimental group had their training while the control group didn't for maybe a month or so, and then everybody was tested again. And so it's going to be repeated measures. The first 3 steps for cleaning your data: always save a backup of your original data file as soon as you receive it. So a researcher sends you the file, you're going to save it. Usually what I'll do is I'll make a client file. Inside their file, I'll make another folder that says from client. And inside there, I will put anything that I get from my researchers or from a client, untouched, unmodified, in their folder. So if I do make any mistakes when I'm cleaning data, I can always go back to that original file. So always save that. Next thing you want to do is save a file if it's not already this way. If it doesn't already have unique identifiers for each person or each record, you need to do that. There's nothing worse than going into a data file, doing a lot of work, cleaning it, sorting it, moving things around, ascending, descending order, and then find out, oh, I didn't give anybody an ID, and I have no idea what I'm going to do with this one record that had maybe an age of 240. I don't even know which person it is. So you want to make sure that you give everybody a unique identifier, save your file again with a different name. Maybe a working file or something like that. So, you're not touching that backup file. And you might have more than one backup file. I mean, very often when you're cleaning a large data set or it's very involved, you'll have many, many backups because you don't want to go back to the very beginning. Say you've been working on a data set for 3 hours. You want to back up every so often, every few steps, just so that if you do something wrong 3 hours in, you don't have to go all the way back out and start over. A note, unique identifiers could be anything. Usually they're numeric, but I said they could be colors, animal names, doesn't matter, just as long as everybody's unique. Save the file. I usually save it as a working file, and then that's what I will use to make the changes. Okay, so let's go to the next screen. Oh, there you go. Steps 4, 5, 6, and so on. Back up often. Can't tell you enough to back up often. So let's look at our raw data. We have some raw data here from the study. Okay, here we have our group. Okay, we have 1 is your experiment, or 1 is your control group actually, and 2 is your experimental group. We have age. As you can see, all the variable names are across the top. Usually that's the way you get it, but it's usually the way the researcher put it in. So what they did was they made their little code book at the top of the page here. So if they're gender, if they're coded as a 1, they're a male. If they're 2, they're female. So they already did a little bit of coding on their own. However, you'll find it will need to go back for the regression and change this a little bit more, detail it out a little bit more. But as you can see in this file, we do not have unique identifiers, right? We do have what group they're in, but we don't have, so that's what we need to do first. So let's go ahead and do that. A lot of times it's better to clean your data in the Excel file. Get it all in order. A lot of people are used to Excel, know how to manipulate things in Excel. So why not just clean it in Excel and then upload it into your software of choice? And most softwares will take it. In fact, I don't know of any software that doesn't take Excel. So if you clean it in Excel, it's ready to go in anything you want to put it into. You just need to clean it according to the guidelines of the software you're using, which we'll cover in a minute. But right now we need to give it a unique identifier. So I'm going to click here on this column and highlight the whole column. I'm going to go into Insert. I'm going to insert a column there. I'm just going to call this one ID. Now, it might be better to sort so that because you have your ones and twos all interspersed together. So I'm going to go over here and I'm going to sort. So let me go over here. We'll go to sort and filter. We're going to sort smallest to largest. And it's asking me if I want to expand to selection. Yes, I do. You want to make sure that you're expanding across the board. If you don't expand this, you're only going to sort here on this column. And you want everybody to go with it, right? So you want this to remain with this and all this person's scores to remain with this number 2 here. So let's go ahead and yes, we'll sort it. Okay, now you can see they're all in order. I can start giving them IDs. So I'm just going to give them numeric. I'm going to do 101, 102, 103, and this will be for my groups ones. So then I'm going to go ahead and highlight this instead of putting them in all the way down to do 50 or 60 of them. I'm just going to highlight that, and there's this little square here, and I'm going to go over it and pull it down, and as you can see, there's our numbers. And most of you that are familiar with Excel know this. So we are going to do that. And then we're going to, right here, I'm going to make this will be 201, 202, because they're group 2. So that's how I'm going to know from my unique identifiers that if they're in group 1, they're going to have a 1 in front. If they're group 2, they're going to be in the 200 series. So I'm going to do the same thing here. Why is it doing that? Maybe sometimes you just have to put another 1 or 2 in. Oh no, so let's do it again. 201, 202, 203, 204. Okay, let's try. There we go. So down we go. So we got their little unique identifiers for everybody. And right there I can see there's a problem because there's group 22. Nobody should be in a group 22. We should only have 2 groups. But we will change that. But it's something to make a note of. And you also want to make sure that, as you're doing this recoding and such, that you have an original code book. You need to know how the person, the original researcher or yourself has done this, how you've coded things. So you want to make sure that you have somewhere, keep notes. And you can always go back to your original data file here because this is how it was coded. So we don't touch that one. So you can always go back. But rather than opening and closing files, you just might want to have something written down or a code book of some kind. Okay, so we did that. We added that. So I'm just trying to read through my notes from a month ago here. So we added our column. Okay, now I'm going to save it. I'm going to save this, and I'm going to save it as ID data file right here, okay? But I'm not going to save it right now, but I would. Normally I would save it like that. But let's go ahead and open up this ID data file. And okay, so we're going to say I saved it. So here we go. All right, so here we are with our IDs, okay? And then we gave the new name, and let's give it the working data. This is our nice ID file. So we're going to keep this as a backup. So we have everything in here originally as it was with our IDs. We're going to go ahead and we're going to call it now working data file, okay? So we will go ahead and call it that. Now I can do any manipulation I want to. They have their IDs. We're ready to go. So let's go ahead and start cleaning it up so we can upload it into SPSS. Okay. You have to think about the software you're going to be uploading to. A lot of them have conventions on what you can and can't use for variable names. If you look back at the data file for the Excel and we look up at our variable names here, we can see that we do have some here that have these little parentheses that we probably can't have. We can't have all this. The conventions for SPSS, which is what we'll be using today, are that each variable name must be unique. Okay, and that makes sense. You don't want more than one column with the same name. Of course, that just makes sense. A variable name must begin with a letter. No spaces. You can't include characters other than a letter or a number, so no question marks, no exclamation points, nothing like that. Variable name can't include single words that are used as commands like NE. You can't, because that means not equal in SPSS, so you cannot use a variable name like that. And we don't want it to exceed 64 characters. In versions 11 and earlier, you can't exceed 8. And I think SAS is like that too, where I think you can name it more, but it'll only show you maybe 6 or 8 letters in the name. So I've rarely had to, use 64 characters in a variable name. You want to keep it simple, but you also want it to make sense if you ever have to look back in a couple months or a year down the road. And that's another reason to keep that code book. You can know what you called them, and how you coded them. You need to keep track of that because you're not going to remember down the road, and you might need to. You might need to look this up. Okay, so let's go ahead and look at this. So let's see. Right now we have them like this. I went ahead and gave them some proper variable names. So I'm going to show you that, and I resaved it. I resaved it under, what did I resave it under? 2 working data. Okay, so I'm go up here and I'll show you rather than go through and change it all. But you know how to do that in Excel. You would just go in and you would type in the new name, right? So you group, right? On you go. So I changed this to age, gender, ethnicity is just ethnicity now, but I remembered what the codings were so that, if I need to go back, I can go, oh, what was 6? 6 was other. 1 was white. Status was full-time, part-time. I know full-time was 1 and part-time was 2. If they ever used biofeedback, it was coded 1 and 2, so I know that. Now, even though I changed the name, but here you can see I put underscores in because you can't have spaces, right? I went ahead and coded these too. These are our perceived stress scale scores. We have before and after scores. We have 14 items on the pretest and 14 items of the scale on the post-test. So as you can see, I named them PSS1 T1, 2, T2, here's question 3, T1, and then further on here, I start over here and we have time 2, and so on and so forth. So here's our PSS1 at time 2, the second item at time 2, and so on until you get to the very end where you have the PSS14 time 2. Okay, so now they're all coded correctly as far as the variable name, so we can go ahead and upload it into SPSS. And it's pretty simple now. So let's go ahead and close out of here. I'm not going to save it, but normally I would, of course. So let's go into SPSS and load that up. So I'm going to go in, and it takes a little while to warm up. So come on, SPSS. There we go. As you can see, we have version 22 here, far from 11. I don't know anybody that have 11 now. So get your blank SPSS file. We're going to go into File. We're going to go into Open, and we're going to go to Data, and we're going to find it wherever you saved it. And I saved mine here, I think, and I saved it here, and I saved it here. To go through the big maze, all our old webinars. Here we go, data for example. Right here is just showing all the SPSS files, but what I need is the Excel file. So I'm just going to go down here where it says files of type, and I'm going to find my Excel. Okay, there they are. Okay, so this one we called, what did we call this one? 2 working data, right? That was the one, our final file that we've saved. So I'm just going to click on that, and it's down here now. I'm going to open it. We have the variable names are in the first row of data, so we're going to read that in. This you don't need to worry about. Just let it go. Click OK, and it should upload. There we go. Here's our variable names, nice and pretty. I'm going to go into variable view. I'm going to make sure they're the type that I want. For this, I want them to all be numeric. They all are numeric, but sometimes you'll get strings. Maybe this gender might be female, male, right? And then it would be string, and you might need to code it into a numeric. But just to keep it a little easier on this, everything's numeric already, so we're good with that. Okay, so we're going to need to combine some scores now because the PSS, let's go ahead and look at that. We have a perceived scale, the perceived stress scale, okay? And I have something, I'll send all these files along with the PDF and the recording, then you can play with these yourself. This kind of tells you about the perceived stress scale. And there's different scales. We have the 14-item scale that we're going to be working with. Okay, and it kind of tells you how to code it. And usually you'll have something like this that says, well, you need to reverse code some items. And then you need to add them up. And that's what we need to do here. Okay, so here I'm not sure. Did the researcher reverse code it or not? Usually you can always ask the researcher, always ask the questions. Did you do this? You know, did you code them? We should save this file. We'll save it as, let's see, what do we want to save it as? Let's save it as, we'll save it as data, okay? And then let's save it as working data. Okay. And normally it wouldn't be where it's replaced, but because you would just be saving it new, right? But okay, so let's go ahead and take a look at these perceived stress scores. So we're not sure if they've been reverse coded or not yet. One way you can look at this is to look at Cronbach's alpha. Let's go back here. Oh, I guess first maybe we should do the frequencies. Let's go ahead and look at our frequencies first. Let's make sure before we go into coding and reverse coding and all, we should make sure everything is correctly in there. So I'm going to go into Analyze. I'm going to go into Frequencies. I'm going to click on these different things here. And just take a quick look at all the variables just to make sure that we don't have anything off. Okay. And if Heather was here, she knows how to put all these in at once. I have to do them like this. Something that, you know, I always say I need to figure that out, and then I don't get around to it. So anyway, we just did that. We clicked OK. Here we have all our variables that we put in. We're just going to take a quick look. First, we want to look and see nothing's missing. 112 all the way across. So that's nice. We don't have to worry about that. That'll be our next webinar. We'll talk about missing data. Here's group. They could be a 1 or a 2. Well, I have somebody here that's a 22. I have one person. So I'll need to go back and check that. I'll need to ask the researcher, was that person in group 1 or group 2? You know, and have them check. Most likely what they did was they meant to say 2 and they just hit the key more than once. You know, you get tired, you do things like this. Okay, but age looks good. These are supposed to be college students, so 18 to 34 is fine. If you had somebody in here that was 209, or if you had somebody that was 4, you might, you know, have to look at that and see. That again could be something, just a data entry error. Gender looks fine. You're only 2 genders. They're right there. Ethnicity, I think we had 6 categories, so we're fine. Some of these other things are fine. Ever used biofeedback? It was a yes or no. That's fine. And now our PSS, each item is supposed to be scored from 0 to 4. If you look at the PDF, it'll tell you about that. So I want to make sure that we don't have anything strange like a 10. Now you might have a 0 missing, and that's fine. You just want to make sure that you only have numbers that you should have, 0 through 4. Okay, so I'm just going to take a quick look down here and make sure everything, oh, there we go. Here's one that's 5. So I'm going to make a note of that and say, well, there's something off here. One person here has a 5, and that was on the PSS 14 score at time 1. Okay, so that looks off. So we'll look through the rest of it, and everything else looks pretty good. Okay, so what I would do is go back to the researcher and say, you know, what about that group? Okay, well, they'll say the group, it was actually should have been a 2, so I will go down and I will change that to. Okay. Now, sometimes you have a huge data set and you found that 1.5 that was off and you need to change. And let's say they said, oh, that should have been a 4. You could, if you had a data set that had thousands of records or tens of thousands of records, you certainly don't want to go over here and start going up and down looking for that 5. So what you can do is you can sort. So again, this is another reason why you have those ID numbers and such, because you're going to be doing a lot of sorting, a lot of moving things around. So I'm going to go into data. I'm going to sort cases. I'm going to sort by that PSS 14 at time 1. I'm going to put that over here. And I want it ascending. You could also do it descending. Yeah, let's do it descending. Instead of starting at the 0, we'll find that 5 right away. It'll be right on top. So let's click descending. We click OK. Okay. So what it did was it sorted all those records according to that variable. Okay, so we have PSS 14 time 1. There he is. There's a 5. Okay, so we change that to 4. That's it. Okay, so we know we made all our corrections. Okay, so we did good there. All right, so after we do that, we want to make sure that we reverse coded, or were they already reverse coded? And say you could call the researcher or email the researcher. Did you reverse code these? Oh, I don't remember. I might have. I'm not sure. Okay. What we can do is use a Chromebax Alpha, check the reliability and of these scores, and see maybe it'll give us an indication. Chromebax Alpha. Let's go back into our little slides here. I guess first of all, I should tell you, you want to make sure the data makes sense. Like I said, if you have a person that's 209 years old, obviously that's wrong. If you have only two groups, an experimental and control, and somebody's in group 22, obviously that's wrong, right? So kind of know what you're looking at, know what your data is about. You want to make sure that you've cleaned it pretty good thus far, you know. Before you start combining and transforming and summing them and reverse scoring them, just make sure you have everything right at the beginning as far as what should be there. Okay, so let's look at the PSS 14 again. They completed this PSS 14 survey 2 times, before the biofeedback and after the biofeedback training. So there's 2 sets of scores, right? T1 and T2, time 1 and time 2. So let's check the reliability. We're going to use Chromebax Alpha. Chromebax Alpha is a measure of internal consistency reliability. What that means is that, is the instrumentation good, reliable with the data you collected? Sometimes you might have an instrument that's been used quite often, but maybe you're using it on a different population of people. Say maybe it's never been used on students before. Say maybe it's only been used on nurses. Okay, and so students might not understand the questions like the nurses do, or they might understand them differently. So you just want to make sure that the data you've collected is going to be reliable with this, that this instrument's going to be reliable with the data you collected, right? You don't want to you have it where these people are scratching their head going, I have no idea what this means, so I'm going to answer some strange thing because I'm not sure. What we can do is we need to go in and check our reliability, and that'll give us an indication of where we are with things. So first I'm going to go up here, Analyze. I'm going to go to Scale. I'm going to go to Reliability Analysis. What I'm going to do is I'm going to put in all my items from the PSS at time 1. And I looked at the documentation for this PSS, and it said what you need to do is reverse code some of these, add them up with all the rest of them for this time period for time 1, and that'll be your score. So you're going to get some overall score from adding the items. So I put them all in there for the 14 items of time 1. I'm moving them over. I have alpha is what I want. I'm also going to pick item, scale, and scale of item deleted. Sometimes, even if they're coded right, one item could be off. Maybe the people didn't understand one of the items. So if you took it out of the analysis, it would improve your Chromebax Alpha. What we're looking for is a Chromebax Alpha score of 0.7 or higher. That's acceptable for reliability. So let's go ahead and look at it. Hit continue, hit OK. Oh, 0.229, that's very low. That's much lower than the 0.7. Okay, that we're looking for. If we go down a little bit further here, here's all our little items, all 14 of our items. If we took out any one of these items, it would improve or change it. So say we took out this time 1 PSS 1 score, our Chromebax would go to 2.46. And what did we have? It was 2.229. It improved a little, but still, if you look at this, if you removed any one of these, you're not going to get up to the 0.7. So something's going on, and we could do the same thing for the second one at time 2, and I did. We would get an alpha of 0.120, and you can try that on your own. Just do the same thing I did at time 1. Just do it for the time 2s, and you'll see that you got this 0.120. Again, much too low. So why are they so low? Well, we look at our instrumentation, we see, oh, we need to reverse score. Okay, the PSS 14 should be scored so that higher scores are associated with greater perceived stress. So half of the survey items you can see are kind of negatively worded. However, these other items here are positively worded. So they need to be reverse coded so that the scores can be computed and they're all kind of measuring in the same direction. If we go back here and look at it, Let's take a look real quick. Up here, here's one that should be reverse coded because it's positive. In the last month, how often have you felt that you were on top of things? Well, that's a good thing. So, oh, very often. Okay. Well, here's another one. In the last month, how often have you been angered because of things that happened that were outside of your control? Well, if you're saying very often on that, you're a very confused person. You don't know, am I happy? Am I sad? Or it could also be bias. A person could have went in and took the survey and just clicked 4 for everything. Very often, didn't even read anything. So that's another indicator. Sometimes that will wreak havoc with your Chromebax Alpha too, people that are doing things like that. So again, get to know your data, kind of look through it, you kind of just need to be an investigator and see what's doing this. In this case, I know what's doing this. I know it hasn't been reverse coded, and at least I'm making that very strong assumption, and I know I'm right because I looked at this before. And so I know, but we say the researcher doesn't know, so we check this. Oh gosh, I don't know, but it could be that they're not. So let's go in and reverse code some things. And so we'll go in here. So what do we need to have reverse coded? We needed, what did I say? 4, 5, 7, 9. Okay, 4, 5, 6, 7, 9, 10, and 13. So you can go this way. You can do them one at a time if you want, or you can do them all together if they're on the same kind of recoding scale. This one will be kind of easy because it is. You could go into transform. You can recode into the same variables, or you can recode into different variables. Normally, I would say recode into a different variable. So for this, say for item for the PSS 4 at time 2, I would go ahead and recode that into a different variable, maybe name it PSS4 time 2 recode, okay? And how you would do that, you would just go in here, recode into different variables. We would put this in here. Let's look at T1 because that needs to be recoded too. So we'll call it PSS4 T1 recode. Okay. Now what we're going to do is we're going to go into the old and new values. So what we're going to do is if they're a 0, they are going to be a 4. If they are a 1, they are going to be a 3. If they are a 2, they are still going to be a 2. And now that's kind of redundant, but I just like to put it in there just to be sure. I mean, you could leave it out, but then there's no telling what SPSS can do some kind of strange things sometimes, or it's me and SPSS together, whatever. I just like to kind of make sure my bases are all covered. 4 is going to be 0. Okay, and I always put in if they're missing, I'm going to make them missing. I'm going to keep them missing. Even though we had no missing data here, it's just safe. I just like to play it safe. So we're going to continue. We'll click change. There it's changing it from this to this with the recode. We're going to click OK. We're going to go back into our data just to look at it. And here's been changed. They put some decimal points in there, but that's fine. So here's our new variable. Okay, you can always check it. Check your frequencies against each other. So let's go ahead and reset this, and we will go PSS4 time 1, and we're going to check it against the recode. And what we should see is that they're just backwards. So before they were recoded, we had 2 people that said 1. Okay, after 2 people said 3. Okay, and that makes sense because we wanted to make the 1s into 3s, right? The 2s stayed the same. See, they're both 47. If they were a 3, there were 51 of them, but now they're a 1. Okay, and the 4s were changed to 0s. And so basically, they're correct. Okay, so you just kind of want to make sure on that, make sure that you coded it correctly. But let's go ahead and we can do them also on the same variables. Okay, so let's go into recode, transform. Recode in the same variables. Now I'm going to do them all at once. We're going to make this real easy. Okay, instead of doing one at a time, I'm going to go, okay, what do I need here? I need, what ones were we changing again? Where are they? Keep losing my notes. Okay, so 4, 5, 6, 7, 9, 10, and 13. Okay, so I can do that. I can also go ahead and just put in the ones for time 2 also, because they're going to be on the same scale. But let's just do it with the time 1. So I've put them all in there. Old and new values. Again, I'm going to do the same thing. If it's a 0, it's a 4. If it's a 1, it's a 3. If it's now a 2, it's still going to be a 2. If it's a 3, it's going to be a 1. And if it's a 4, it's going to be a 0. And if it's missing, it's going to stay missing. Okay, so I look 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. Good. Looks good to me. Continue. And okay, done. Okay, and again, you can go back and check your frequencies if you want, and just to make sure that they did reverse and they're just opposing like we did here. But trust me, they're done. They're changed. They look good. So we would go ahead and do the same thing for time 2. And then, of course, you wouldn't have all the recodes here. They're already coded in here. So like I said, just to play it safe, you might want to do a recode, just a whole new variable. However, if you're pretty confident and you know everything's going to be okay, you can go ahead and recode them on the same variables. Just know that once you do it, if you make a mistake, you can't change it back. So it's kind of nice to have your recodes here, and then the original things aren't touched. So you could go either way with it. I just wanted to show you both ways. Okay, so let's see where we're at now. We went ahead and did them. Let's go ahead and look at the Chromebax Alpha. It should be working fine on the first set of items. Let's go in. We recoded them into scale, reliability. Okay, they're all still in there, so it's a time 1s. Okay, so just make sure. Got my alpha. Okay. Look at that, 0.797. So obviously that's what it was. I mean, it could be that it wasn't that. I mean, you never know for sure, but most likely it was, because we needed to reverse code. So we should get a similar kind of thing for the time 2 when we recode. So good. So let's go back into here, and I already showed us how to do this. So we're above the 0.70, which is acceptable. We had 0.795, and then if I go ahead and recode time 2 and run it, we get a 0.856. So now we're good. We recoded them. They're nice. They're ready to go. Well, now we need to add them up, because now we need to make the scores, right? So we need to add up the time 1 scores, and we need to add up the time 2 scores. We're safe to do that now because they're all reverse coded. Their Chromebax Alpha is good. We're looking nice. So to do that, let's go ahead into the working data again. And now we're going to go into transform. Now we're going to compute a variable. So let's call it some PSS T1. Whoop, T1. Okay, well, we're going to call it a sum PS. This will be our total. Okay, and then what we'll do is we can either go in here and pick sum. Okay, and then all you need to do are pick your variables. Oop, we'll take that little question mark out. So I'm just going to say, okay, some PSS time 1, and then you have to put a comma in between them. Okay, so PSS 2, and another comma, 3, comma, 4, comma, 5, comma, 6, comma, 7, comma, 8, comma, 9, comma, 10. And actually, you know, there's syntax too you can use if you want to. I'm just doing the point and click because that seems easier for a lot of people. Okay, so they're all in there, and then there's little brackets, okay, and then we click OK. So let's look back at the data file, and we go way over to the end. That's usually where they put the new ones. And there you have it. Okay, now they're all summed up for time 1. And we would do the same thing for time 2. Okay, but remember, I didn't reverse code in time 2 here, so what I'll do is I'll close this out, and we're going to save the new data set. We're going to save it under a different name, right, because we're backing it up. So I named the PSS score time 1 and PSS score time 2. Okay, so now I saved it under analysis data save. Okay, and then we're going to be performing a multiple regression. with the following model specifications. Okay, now here's our multiple regression. We want to put in age. We want to put in gender. We want to put in ethnicity. We want to know if they've used biofeedback before or not, yes or no. We also want to put in the score at time 1, and we want to put in what group they are in. Are they in, the control or the experimental? And then, of course, you have your little error here, which is you always have in the regression. So what we're going to do is we're going to run a model and put in these variables. But if we use the data as it's coded, we're not going to get valid results. Okay, so we need to be careful. You think, oh, okay, I'm just going to go ahead and throw them in. I'm ready to go. If you look at these variables, right now, gender, for instance, is coded as a 1 and a 2. Okay, what we really need is to have them coded dichotomous as 0, 1. When you have things like that, we need to do things called dummy coding. So we're going to go ahead and look at that a little bit more. Okay, so the reason they're going to be invalid. Gender right now is coded as 1 male, 2 female. If we use these codings, we're using math that makes females of greater value or higher rank than males. That's not necessarily true. Females are 2 and a male's 1. That doesn't mean females are better. But SPSS, the regression model, the math of it doesn't know that. So it's going to put in, oh, well, it's a higher rank, or it's, it's a higher level. Previous use of biofeedback, same thing. Coded 1 yes, 2 no. So similar to that coding for gender, with this coding, if you haven't used biofeedback, you're mathematically of greater value or rank than those who have. So that doesn't make sense. And you'll see this a lot where it'll be 1 yes, 2 no. Race, ethnicity, that's a real mess. You have 1 to 6, right? White is 1, black is 2, others 6. Well, if we leave this coding, then we're saying that those who are of other race or ethnicity, they're a larger value or higher rank than the others. And we know that there's no higher rank, right? It'd be the same thing with colors. If you had blue, yellow, green, one's not better than the other. Maybe personal preference, but, empirically speaking, no, there's no difference. So we need to dummy code categorical variables. So when they're nominal, when they're categorical like this. And it's not too hard to do. It's a little confusing. But first, let's run the model with the coding as it is. So I did. I don't necessarily need to do it here, but let me go ahead and get the right file. I want to change it to this. All right, let me see if I can get the... Okay, let's see. I have analysis data and correct analysis data. So let's go ahead and I'll just show you the output, and then we'll go ahead and run it with the correct. But with the coding as is, hey, we have a very nice R squared here. Over 50% of the variance is explained by those predictors. It looks really nice. Our adjusted R squared is very nice, still over 50%. It's significant, big F, little p value. We put in all our predictors, right, that we said we were going to put in. It's significant. It has a great R square. These are indicators of good model fit, but is it really a good model fit? Is it really a good model? It's not. But we have 3 significant predictors. Here we go, right here. They're all with a p-value of less than 0.05. Right here, gender has a coefficient here of a negative 2.3, a coefficient here for your score at time 1, group membership, whether you're in the experimental or the control group, that's significant too. So we have all those 3 ones. So let's interpret it using the code that we had. So this is saying, if we look at a regression, for each 1 unit increase in gender, the PSS 14 score at time 2, the post-stress scores, decreases by about 3 points. Well, when you think about that, you go, well, what's a 1 unit increase in gender? That makes no sense. This is basically, if you leave it like this, you're saying that when gender goes from a 1 to a 2, that your stress scores decrease at time 2. But we're not really increasing gender. Gender isn't an increase-decrease kind of thing. And if you look at increase in group, so let's see, we had it coded where 1 was control and 2 is the experimental. So it's saying that for each 1 unit increase in group, that your score at time 2 decreases by about 0.62 points. But again, what is a 1 unit increase in group? It just does not make sense. The score time 1 does, though, and because it's a continuous variable, and you can read it that way. And actually, the score at time 1 is saying that for every 1 point increase in your score at time 1, your score at time 2 is going to increase by a factor of about 0.77. So it's basically saying if your scores are higher here, your scores are going to probably be higher at the end, which makes sense. You're already stressed. Your stress is. I doubt the biofeedback might help some, but I don't know how much it's going to really help. I mean, if you're already stressed, you might have a decrease, but how much? So that kind of makes sense. However, the other ones don't. So your model is not really good. So think about this: if ethnicity were significant, how would we interpret that coefficient? Say this was significant. Say, it's not, but if it was, well, you'd say, well, gee, for each 1 unit increase in ethnicity, again, it makes no sense. There's no increases in ethnicity. So we need to be careful with this. Hey, it looks good. We got some really good output. We got some significance, but it's wrong. It's not valid. So what we need to do is make sure our coding is right. So here's another way of looking at it. Let's put those coefficients in there. Okay, so here's our model, and here's where we put in our little our B's actually. So our constant was 8.37, and then we took 0.11 by age. That's okay. Gender, here's our negative 2.38 times gender. So another question to ask is if we had only the constant term, which is the 8.37, which basically would be your mean score on the PSS score at time 2. So that would be your mean score would be 8.37. When everything else is equal to 0, that's what your constant is beta naught, your 8.37. What type of individual would that mean score be for? Would they be male or female? What ethnicity? What group do they belong to? We don't know because they're not coded correctly. But if we have a reference point for these and we dummy code them as 0s and 1s, then we can make more sense out of this model. Okay, so that's what we're going to do. So let's go to the next screen. One last comment. Again, I'll say it again. It sure looked good. It wasn't valid, but it sure looked good. So there's a rather good scenario for the garbage in, garbage out. Okay, this is why we need to think about what we're doing. Numbers usually look really nice. So back we go. Let's do dummy coding. Okay, this is the fun part. Now this is when, just bear with me, play with it yourself, and it'll make a little more sense to you. But this is important to know. Just like the concept and techniques of data cleaning, dummy coding, it can get quite a bit involved. So I'm going to try to keep it simple as possible. Dummy variables also are called indicator variables. It's much more PC, but you'll hear them referred to as dummies. Statisticians will always refer to them almost always as dummies. I did have a client once that refused to let me call them dummy variables and actually made me call them indicator variables. He found it offensive, and that's fine. So call them indicator if you want, but just know that this is what they're mostly called. They consist of only 0s and 1s. Okay, so that's why they're called indicator variables, because if they're a 0, they're going to zero out things. So you won't even see it, right? It just takes it out of the mathematical formula because we're multiplying things here by those coefficients. So if you multiply by 0, you're going to get nothing. But if you have a 1, then that's multiplying by 1, and you have basically the same thing, right? Anything multiplied by 1 is itself. But you'll see that a little bit more as we go on. But they're used to identify the categories of your nominal variable. Now you're going to code one less dummy variable than you have categories. K minus 1, you'll see that often. K is your number of categories. For instance, K minus 1 categories, what we'll call the reference category or the reference group. It's the one that we're not coding. It'll be the mean score at time 2 for all the reference groups. So for gender, let's code males 0 and females 1. Therefore, males are the reference group, because when gender is coded as 0, then nothing extra is going to be added to that 8.7 or for whatever that constant is, right? So that's going to say, okay, when we have females, then we're going to add a little bit more to it. But when they're males, zeroed out, that's our reference. Okay. Use of biofeedback. Let's code no equals 0 and yes equals 1. That way, if a person's not used their biofeedback before, then this is a person who's our reference, okay? And any additions to that post-test score, that post-intervention score at time 2, is going to be from a person who has used biofeedback before. Because if they're coded 0 and they've never used it, they're just taken out. They're a reference. Gender, same thing. Oh, gender. Nah, it's not gender. This should be group. I'll fix that. I'll have to fix that. Slide 21, I will fix. This should be dummy code for your group. Control is 0 and experimental is 1. Therefore, the control group is going to be our reference because they're coded 0. So as you can see, those 3 variables had 2 categories each, right? Gender only had 2. This only had 2. Gender, or again, the group, yes, or is a controller experimental. So I know if gender is coded 1, we have a female. 0, we have a male. That's all the information I need to know about gender. I don't need to have 2 dummy variables, one for female, one for male, because I know if I have a code on gender of a 1 or a 0, that right there gives me all the information I need. Again, that's why you only need 1 less when you dummy code, because your reference group will be across the board when they're all 0. Let's look at ethnicity. That's a good example of that. It's a little bit trickier. Most of the records in our data set are either white or black. 56 of them were white and 39 were black. 17 are coded with a 3, a 5, or a 6. And they were Asian, Hispanic, or other respectively. Okay. Now, I might suggest only including white and black because there's just so few of these others. Only 17 is kind of unequal. And that would mean just 1 dummy coded variable. We would basically code these guys as missing. These 17 is missing. Only look at these records here, which that reduces your sample size. It reduces your power. If you can include those 17 somehow, that would be great. However, including them on their own might not be so good. So we might need to group them together as Asian, Hispanic, or other. What I'm going to do is, for ease of showing you this, I'm going to make it 3 categories. Just to make it a little bit easier. But these are dilemmas you'll find in your data cleaning all the time. It's like, oh my gosh, I only have, you'll find it a lot. I have American Indian. I only have 2 people. Well, you can't really include them in their own group. They're not going, you can't even really get a good mean on those because there's only 2 of them. So you might need to, combine them with some others. But that, again, is at your discretion. If you have a good justification for it, awesome. Usually somebody else might code it another way. If they have a good justification for it, awesome. You'll find the statistics can be very subjective. There's no cut and dry most of the time. So as long as you're making sense with it and it makes sense to you and it theoretically makes sense for your field of study, or maybe you can look at the literature, see how it's done, how it's been done before. Just be informed about it and do your best. I'm going to do 3 categories just to make it easy on us, okay? So I'm going to do white, black, and other. So I'm going to include all these people and other, okay? I'm going to make 2 dummy variables because we have 3 categories, race, black, and race equals other, and I'm going to make white the reference group, okay? Because another convention is if you're not sure who to make a reference group, the convention is to use the one that has the most records in it. But not always. If you're really interested in black being your reference group, make them the 0. Zero them out across the board, and include white in your model. However, again, it's up to your discretion. There are some conventions, but whatever makes the most sense is going to answer your question. So let's go to data and code it, run a regression model again. Okay. Now we have the file with the dummy coded variables, and we named it correct analysis data safe. Let's take a look at that. I already showed you how to go in and recode, right? This one's not going to be too bad to just show you, I think. You'll get the gist of it. So we're going to go in here. All right, so here's our ethnicity coded this way. Did I recode it on the end? Yes, I did. So here's what I did. I took the ethnicity, right? I have race black and race other, okay? So I would go into the transform. I would recode into different variables, okay? Because now we are making a new dummy coded variable. I would bring in ethnicity. Okay. Output variable, we're going to call it race, black. Okay. I'm going to go in old new values. Now black originally was a 2. So if there are 2 on the original data, they're now going to be a 1. Okay. All other values are going to be a 0. Okay, because now we're just coding if they're black. Okay, and then of course if they're missing, I always like to put that in there. It's just the missing. Okay, and then continue, and then change. And now it's telling me it duplicates an existing variable name because I'm basically just overwriting that to show you. If you didn't have it there, it wouldn't ask you this, but I'll just say okay. We're going to look at it. Okay, but it's basically you would do that. And for the others, if they were coded. Let's go back in here, recode into different variables. We're going to call it now, we're going to call it race other. We're going to change. Nope, oh, we don't want to change yet. We want to go into our old and new values. Now, if they are, what, a 3, they're going to be a 1. If they're a 4, which I don't think we had, that was a Native American, they're going to be 1. If they're a 5, they're going to be a 1. If they're a 6, they're going to be a 1. Okay, and all other values are going to be a 0, else 0, and then the missing's there. So continue. Now we'll change it. And we'll hit OK. And so there we have it. And you might want to, run your frequencies again to check and make sure they make sense. In fact, you could do it this way. Just go in here, frequencies. Let's go into ethnicity. And let's go here, black and other. Put them in there. Let's run them. And let's do some math. So here's our original variable. Here's our race of black. Here they are. Now they're coded 1. There's 39 of them. See? And there were 39 of them there. Good. Now others, what we had, 2 and 7 is 9, 8, 17. There they are. 17 are coded as 1 and the others are 95. So there you only needed 2 because our only other category was white. Now you go, well, what about white? They're not here. We didn't code for them. We didn't have to because if, say this person here, all the information you need for the 3 categories are in these 2 variables. If I look at this record up here, the top record, I can tell they're other race because they're coded as 1. The second one is other. They're also another race. Oh, here, this record down here, record 6 is he's black or she's black. We have to look at the gender, right? But this person is black, okay? But here's one that has 2 zeros. Well, here's up here too. Here's a couple of them here. Have 2 zeros, one for black, one for other. That means they're white because they're coded as 0 on both of these dummy coded variables. Okay, so think about that. Let that move around in your head a bit. But that's why you only need that's 1 less than your total number of categories. Because if there's 0 across the board, that's your reference. Okay, and if you do it where you do code black, other, and white, say you did make a category for white and code it, and you ran it in SPSS for the regression, it'll catch it. And it'll only use 2 groups, and it'll make one automatically your reference, but you won't know, you really don't have much control over who it's going to be. You kind of have to look at the printout and go, okay, what did SPSS do? Who did it pick? So it's better to kind of control it yourself up front. This way I know I'm making white the reference, or if I wanted to, I could make black the reference or other the reference, whoever I wanted, but I'm making that choice. I'm not leaving it up to SPSS. Okay, so there they are. Nice and pretty. So they're all coded. So here's the model with the dummy coding. If I run it, let me see if I can run it real quick, just so you can see. Might as well, right? We're doing a regression. So I think we're all coded here, all ready to go. Analyze. We're going to go into regression. And it's a linear model. So we're going to linear regression. Our dependent variable is going to be our score time 2. Put it up there. And then what do we have? We have group. So we recoded group. Okay, so see I have them all down here coded. Age was already continuous, didn't need to be recoded. We'll just throw them in. Gender was recoded, so I'm going to go back down to the end of the file. There we go. Race, there we go. Now we have 2 of them for race, right? We have black and we have other. Okay, then the score time 1. Put that in. Ever use biofeedback? That's right, we had to recode that. So we'll put the recoded one in with the zeros and the ones. Okay, and I think that's everything. Okay, so we can run some more little statistics. We can put in our descriptives. We can put in these collinearity diagnostic, things like that. Confidence intervals are always nice to have. We can put in these things, get a lot of information. Sometimes we want to save this just to make sure that we don't have too many outliers, multivariate, but we'll worry about that another time. Plots. It's always good to do this. The biggest thing, probably more important than a normal distribution or anything, is that your residuals have a nice scatter. So I'm going to put a predicted there and my residuals there. Okay? And I also want to look at the histogram because I want it to make a nice normal histogram for me. What else we have there? Well, we don't have to worry about this. That's if we had missing data, so we'll leave that. Okay. All right, so let's hit OK. Okay, there we go. So we have some descriptives here. We have some correlations here. Here's our model. Ooh, look at that. Nice R squared. And adjusted. Okay, much better than before, actually, because before we have a 0.5, something like that. Now it's gone up. Model's still significant. Down here we have some, here's our constant now is 10 instead of 8. Okay, but it's going to make more sense now. You know, it looks the same. Oh, here's, we still kind of have this going on here, but now we have some more information here and more information here. So let's go back in here. And here's our output. Okay, here's our model. It looks really good. And here's our model with our dummy coding. We still have the same 3, right? I think these were the same ones as before. It's going to make a little bit more sense now, okay? And you're going to see right here, this is going to make a big difference. And this was the big thing, right? Is there a difference between the control and the experimental group? Okay, so now here's how we're going to interpret it. Now it's going to make sense. Scores on the time 2 outcome for stress, they decreased about 2.6 points for females when compared to males. Okay, now it makes sense because males were zeroed out there to reference. Actually, when you look at this here, this constant, again, that's your mean score at time 2 on the stress, your mean stress score at time 2. For who? Right? Remember we were asking that before, for who? Well, now we know because we made the reference categories males, we made the reference category white, and let's see, who else? Oh, and they never had the biofeedback before, right? And also the reference category was also control, the control group versus the experimental. So compared to males, this makes sense, okay? Scores on the time 2 variable decreased by almost 8 points for the experimental group when compared to the control group. And that's a big difference from the first model, where I don't think it was that much difference at all, less than, like it was 0.7 or something. But now it's saying, wow, the scores really decreased for that experimental group by 7 points compared to the other group. Okay, so now what if ethnicity were significant now? How would we interpret it? Still not, for either of them. However, say one of them was, say black was, say this was significant, then it would be that it goes up, the stress scores go up for blacks by a factor of about 0.32 compared to whites because those are the reference category, okay? And like I said, you can make anybody you want the reference category. I just happened to pick that one. It was the biggest one. But now you can have a better interpretation. Let's look at the model. Let's look at the model. We have a correct model specification now. It's the same way we wanted it, right? But now here it is with our little coefficients put in there. There's our mean, 10.49, okay? Now, if gender was male, this would zero out, right? Because that would be a 0 here, not a 1. But since it's female and it's coded 1, we're going to subtract 2.63 from that score, okay? And then over here, if the race was black, we're going to add 0.32 to this score right here. If they're other race, they're going to be coded as 1, and that's going to be 1 times this, 1.14, right, because it's being multiplied by a 1. So we're going to add 1.14 to the score. So, depending on what your values are here for a particular person, particular record, there you have your nice little predictive model. And it'll give you some idea of given these certain criteria for a given person, what your outcome would be for your time to score. Very nice. So now ask if we had only the constant term, which I was just saying, the 10.49, which is the mean, which is the average value for the time to score, when everything else is 0, then for what type of individual would that mean score be for? Male or female? What ethnicity? Which group? Well, we know, because we know who the zeros are. They'd be male, they'd be white, and they would be in the control group. Okay, and also we'd also know that they never had the biofeedback training before. I didn't put that in there, but we know that too because they were coded as 0, right? So now how we coded out our dummy, now that we know how we've done that, reference groups are right here, just like I said. All the zeroed out people, right? So, and that's kind of nice. So now it makes sense. And the model looked, good both ways, but at least this one is correct. Okay, that's it for that. And so references to learn more, there's some good ones here. A good overview for checking for correcting errors in a data set right here. Here's something from Princeton for how to do it with R and Stata, if you're into those. Stata is a great program. R's free, download it, play with it. You need to, if you have some coding experience, it's more useful, but you can learn it. You can learn anything. You just put the time in. I always have to mention the UCLA website. It's for the digital research and education. It's great. Any software, well, not any software, but the big ones, Stata, SAS, M+, even. I mean, software, R, SPSS, all of them, or all the big ones are in there. And there's all regressions, t-tests, structural equation models, things, all kinds of things. And it's step-by-step, annotated. You just check it out. It's great for, I mean, every webinar I think I mentioned this place. So it's great. I use it all the time. Of course, the SPSS Survival Manual is great. If you're into SPSS, you're working with not too difficult of analysis. It's good. It has regression, factor analysis, t-tests, things like that. But it's a great resource. She has a whole section in the front for data cleaning, start to finish on how to do the analyses. Very, very good book. Nice thing about her book is I think it's maybe $30, $40. So you're not spending hundreds of dollars on a book, and it's very useful. We have a nice dog-eared copy here that we share between us. There's 3 of us always wondering where it is, who has it. So it's a nice one. Keep in touch and informed with us. Check out our blog right here. There's a link to it. Stats Chat. I need to do a little bit more with it. We've been really, really busy this year. People have been sick on and off this year. We're expanding the business, and so it's just busy. I really, really, really want to start, posting to the blog, though, and more on Facebook, more on the newsletters, things like that. More of these webinars. I think they're really useful. So our next webinar is actually about multiple imputation. It's not too easy, but it's not too difficult. I would think it's probably the best way to go. It's a little bit of effort, a little bit of thinking, but it's not like some of the things like an EM algorithm or something like that, and it's a lot better than mean imputation. And if you know anything about imputation, mean's probably one of the worst ways you could go. But, join us, watch us, or just sign up and get the recording to watch it later. Share it with a friend. Sometimes they're a little more difficult, sometimes they're a little easier. I always try to make them as easy as I can. I thank you for attending. There's all my information. Again, if you have any questions, here's my email. Visit our website. Like I said, I'm hoping to put more things on it, make things a lot more interactive for everybody. I'm really enjoying this. I really enjoy sharing the knowledge. I really love how people seem to love this series, so I just want to keep up with it. We don't really have a Q&A today, but like I said, email me. I'm going to let you go. I think I've talked way long enough.